Let's have a look at manufacturing scheduling and optimization in IFS Cloud. Today, I'm going to show you how the new Finite scheduling engine in IFS Cloud will help planners to optimize their production plan. MSO is a built-in finite scheduling solution based on AI and optimization capabilities. I will show you how MSO can optimize the production plan based on changed capacity situation, like a new maintenance activity on a machine. I will also demonstrate how the production planner can use the Smart Manufacturing Planning Board to interact with the schedule. As a production planner, I've just received notice that one of our punching machines has broken down, and there is an ongoing maintenance activity on that machine. I need to deal with the rescheduling of my production plan based on the unavailability of the punching machine. Let's look at the situation. In the Visual Shop Order Operations planning window, I can see that there is a maintenance activity on my punching machine, and that maintenance activity has actually caused an overload of the punching machine. MSO can be run either in manual mode or in automatic mode. In automatic mode, this new maintenance task would have led to an automatic rescheduling of the production plan. But today, I'm running MSO in manual mode and will start the finite scheduling manually. I will do this from the Smart Manufacturing Planning Board. In the Resources view of the Smart Manufacturing Planning Board, I get an overview of all resources included in the finite schedule. As you can see in the tree structure, we can have work centers, labor classes, and tools defined as a finite resource. In the Gantt chart, I can see operations per resource, and I can also see the maintenance activity that is causing the overload. Let's manually start the finite scheduling using the MSO engine. So now we can see the result of the new optimized production schedule where the maintenance activity has been placed first and the operations in sequence afterwards. The reason for this is that this maintenance task is set to be obstructive, which means no production can run at the same time in the punching machine. Let's see what consequences we have from this reschedule. I will change the color by option to look at any tardy operations. As you can see on the Gantt chart, we have 4 tardy operations. I can use the card view to get some better insights about these orders and operations. I can see what part is being produced. I can see when it is scheduled and when it is needed. But as a planner, I can also take some immediate actions, like changing the status of the order, releasing it, or parking it. I could also change the resource being used or split the operation if I think that will help to solve my scheduling problem. When I investigate the details, I can see that 3 of my operations are only delayed by a few hours, but I have one operation that is actually delayed by a number of days. So I need to look into that operation a bit more. And I will again change the color by option to visualize by part number. And what we can see now is that the yellow in the Gantt is represented by the part S, which is the side panel. So this is the part that is delayed, but we can also see that MSO has also ensured production of the side panel earlier in the week and only delayed one of the orders. I now need to deal with the consequences, though. I know as a production planner that the yellow part, the side panel, is used in the welding of the chassis, which is this red part. So by looking at this Gantt, I can see that this shop order for the chassis will probably not have enough side panels to be produced at this time. So as a planner, I want to be proactive and reschedule this order, both to show for MSO that there is free capacity in this spot, but also to show that the chassis part will not be ready in time. I will do this using the operations view of the Smart Manufacturing Planning Board. I will start by filtering for my 2 parts, the side panel and the chassis. Now you can see the shop orders for these parts, and the green lines represent the earliest possible start date and the need date of the order. So for this order, you can see that it is scheduled outside of the green line, meaning it will be produced a number of days after its need date. I can also see that it feeds into this order. I will start by expanding the shop order for the chassis, showing all operations and resources involved in the shop order. So what I want to do is move this operation that I know will not be able to be produced at this time. And I will do that by changing to the insert mode. And now I can simply, with drag and drop, move this operation to the next day where I know I will have the material available. This operation is now fixed, meaning MSO will not reschedule this operation. The responsibility for this operation has been taken over by me as a planner. To confirm and save the changes, I will create a new finite schedule. You can now see the new optimized production schedule, and I'd like to highlight two things. One, the operation that I moved has a small pin, meaning it is fixed and will not be moved by MSO. I can also find all my fixed orders in the side panel, where I could also revert if needed. 2. MSO has also moved in a new operation into this spot where there is available capacity to ensure a high utilization of my finite resource. And this concludes the demo of MSO and Smart Manufacturing Planning Board. I hope that you have gotten an insight in how MSO will help planners to create realistic and optimized production plans, ensuring a high utilization of the critical finite resources, and how the Smart Manufacturing Planning Board will help planners to interact with the schedule. Thank you for listening, and happy scheduling.